When you hammer a nail on a wall and you apply pressure on the flat surface area, you'll find it easier for the nail to penetrate through the wall. Let me ask you a question. What will happen if you apply pressure on the surface area of the nail and I try to push the flat surface area of the nail? Will it find it easier to penetrate through? No, it will not find it easier for the nail to penetrate through the wall. What could be the reason? The reason is that the pressure applied on the nail by the tip of the nail is less reduced, which allows easy penetration of the nail into the wall. While on the other side, the flat surface area of the nail has a bigger area. As a result, the pressure applied is completely reduced and it has less pressure which is applied on the wall. To understand that better, let us first of all define the word pressure. What is pressure? We say that pressure is a perpendicular force acting on a surface area, on a surface per unit area. Perpendicular force acting on a surface per unit area. What is the standard unit for pressure? We know force, the standard unit for force is newtons. And that one over an area is in meters per squared or meter squared. Now, which means the SI unit for pressure is newtons per meters squared, sometimes noted by Pascal, or sometimes it's called Pascal. Why is it called Pascal? It is called Pascal in order to honor the achievement of the French journalist, French scientist called Blaise Pascal for his achievements in hydrostatics and hydrodynamics. That was just purposely in order to honor him. Yes, we had looked at an example of hammering a nail on a wall using both surfaces, both the tip of the nail and the flat surface of the nail. Let us look at another example of the contact between a knife and a lemon. You know, knife has two edges, two sides to say. We have the cutting edge. We also have what is called the blunt edge. In the blunt edge and the cutting edge, let's try to see which one will help us to cut this lemon at ease. For example, when I cut this lemon using the blunt edge and I continue to apply more pressure, you will see how difficult it is to penetrate through, which means it finds it difficult for the knife to cut this lemon when I'm using what? The blunt edge. Let's also look at the example of you cutting the same knife, the same lemon using the same knife, but applying pressure using the cutting edge. You can see here the pressure which I was applying when I was cutting the lemon using the blunt edge was more, and this time the pressure which I applied to cut the lemon using the cutting edge is lesser, and it is around the knife to cut the lemon with a lot of ease. What could be the reason behind that? The reason is that the area of contact between the lemon and the knife on the cutting edge is reduced. Hence, more pressure is applied on the lemon, which allows easy penetration. However, when you cut the same lemon using the blunt edge, the area of contact between the knife and the lemon is bigger. As a result, the pressure applied on the lemon is much reduced. That's why it was difficult for me to cut the same lemon using the same knife but using different sides. That's how pressure acts on the lemon. And the examples we're looking at is when the pressure acts on a solid, which means solids applying pressure on solid. This is solid. The knife is solid. The lemon itself is solid. When solids applying pressure on solids, you saw what happened between when I applied, when I was trying to hammer a nail on the wall. That was, which means the nail was solid and the wall itself was also solid. It was the same thing. So on the other hand, we shall also have to look at how liquids apply pressure. Before we go to see how liquids apply pressure, let me first of all ask you, do liquids first of all apply pressure? How is it done? So we shall look at that one in our next lesson. Thank you very much.